Okay, so we have discussed tropical cyclone activity, trends, response or expected response to global warming and so on. Uh, that was done in the full course that I have on tropical cyclones, or at least a series of podcasts if you don't want to call it a course. Here I found a new paper from Colorado State University group, which is a really good group, and have done a nice analysis. When people do historical trends, typically how far you go back can affect the results, but then you are also affected by the changes in observation systems and changes in the duration of cyclones, because if short-term 2-day cyclones happen on the ocean, they may not have necessarily been recorded because they didn't make landfall, didn't have impact on the land and so on. So the famous Webster, Curry and Holland paper, for example, became very famous in I think 2005, and then it's been debated endlessly, and change in observational system has been blamed for some of the conclusions. This paper then focuses on the period where we have good data from microwave sensors, scatterometers, and even methodological approaches like Hart's phase diagram with thermal winds that we looked at earlier in the cyclone podcasts. So I'll just present the main results here, and the main result really is that overall hurricane activity is not increased, which means it's about storms that have crossed into a hurricane category, which of course are called typhoons and cyclones elsewhere. So tropical storms and hurricanes are looked at, and for each region. So here are the named storms: global, North Atlantic, Eastern North Pacific, Western North Pacific, North Indian and South Indian Oceans, South Pacific. South Atlantic doesn't have really any sample worthy of consideration, and finally Northern Hemisphere and Southern Hemisphere. So statistically significant results are that named storms trend, so the caption for example, per decade linear trends in named storms lasting less than 2 days, named storms lasting greater than 2 days, hurricanes, major hurricanes, category 4 and 5 hurricanes, category 4 and 5 hurricanes by percentage, and accumulated cyclone energy. So there is also two rapid intensification metrics concerned: a 50-knot rapid intensification and rapid weakening episodes, and damage. Okay, so keeping that in mind, we have significant increase. So named storms in a linear trend per decade is for 1980 to 20, I think, sorry, let me make sure, 1990. I should have included that in the caption. Oops. 1990 to 2021. So you have basically 3 decades, and so 3 per decade. WNP has Western North Pacific, which has majority of the cyclogenesis, 30% of the global, for example, has seen a decrease in named storms, and Northern Hemisphere obviously ends up dominating here, and Southern Hemisphere is not statistically significant when you consider all of them. If you look at named storms less than 2 days, then global number has a positive trend, so does the North Atlantic and Eastern North Pacific, but Western North Pacific again has no significant trend. North Indian Ocean is not considered here, it doesn't have enough sample. South Indian Ocean negative but not significant. South Pacific and Northern Hemisphere overall, and Southern Hemisphere is positive but not significant as well. So named storms that lasted longer than 2 days, global negative, no significant, not statistically significant. North Atlantic has seen some increase, whereas Western North Pacific has seen a decrease, and no statistical significance in the other regions. This is important because when people look at just the North Indian Ocean or just the tropical Atlantic, we may be potentially missing something in concluding whether global warming response is increasing cyclones or not. So looking at the global picture does provide some deeper insights in terms of an increase in the North Atlantic but a significant decrease in the Western North Pacific. Those that grew to be hurricanes, so strong categories, globally there's been a decrease, decadal trend. Western North Pacific dominates that trend, which has had a significant decrease, and also overall the Southern Hemisphere obviously is consistent across all these categories as well. Major hurricanes, no significant trends anywhere. Category 4 hurricanes, again some positives and negatives but not statistically significant. Category 4 to 5 hurricanes, not really statistically significant, but there is a consistency in terms of the number of storms that are lasting longer than 2 days. But the big picture here really is that when you look at accumulated cyclone energy, which is a good integral indicator of duration, intensity and frequency of cyclones, globally there has actually been a decrease, statistically significant decrease in accumulated cyclone energy, which comes largely from the Western North Pacific and also the South Indian Ocean, and overall the Southern Hemisphere is negative as well, which is basically South Pacific and South Indian Ocean. If we then look at the intensification, it turns out that if you use the measure of 30 knot intensification in 24 hours, there is no significant trend. But when the 50 knot rapid intensification change is looked at, globally there has been a decadal trend, and there is a trend in the North Pacific as well. So you can imagine that even though the number of cyclones and hurricanes has dropped, rapid intensification has increased. Also, when you look at hemispherically for the Northern Hemisphere, it's larger than the Southern Hemisphere, but both are statistically significant. Damage in billions of dollars globally has gone up. Northern Hemisphere has gone up. North Indian Ocean has gone up, which makes sense in terms of increased coastal populations, exposure increased, not necessarily hazard. So obviously if you look at that way, then most of the increase in damage is related to people moving closer to the paths of the hurricanes and so on. Okay, so this is important to understand because it turns out that when you look at the period where the data is consistent and it is able to identify storms that are less than 2 days long life cycle, longer than 2 days, and categories 4, 5 and major hurricanes, then you get a slightly different picture than you would expect from a lot of the previous papers. So looking here again, global named storm formations during 1990 to 2021, named storm formations in 6 tropical cyclone basins. B is as in A, but named storms lasting less than 2 days, and C here is as in A, but named storms lasting longer than 2 days. So here you have named storms, now not anomalies but totals from all the regions we looked at. Western North Pacific in this color, South Pacific, which is the blue color here, dark blue color. Eastern North Pacific is the light green, South Indian Ocean is the lighter blue, North Atlantic is in this beigeish color, and North Indian Ocean is in this bluish color. So you can see again that overall total number of named storms across the globe, no statistically significant trend in the 1990 to 2021 period, which is a significantly warming period, even though it has the so-called global warming pause in it. But you can see that overall nothing jumps out in terms of particular region. But when you look at named storms less than 2 days, well, actually, let's be more careful here. So if you look at just the western North Pacific, which has seen a decrease, then maybe you can see some difference in the number of named storms here versus here. So the trend line is something we already looked at in the previous figure. So named storms lasting less than or equal to 2 days, there has been an increase across the globe, and as we said, a lot of it came from North Atlantic and also North Pacific, Western North Pacific. Named storms that lasted longer than 2 days, there has actually been a decrease overall in the global number. Okay, so this is something also interesting to note. So this obviously must have some physical basis in terms of the warming of the ocean and the available hurricane potential versus atmospheric changes in terms of, let's say, upper atmospheric temperature, which we will look at in a minute. So this is similar to the last figure, but for hurricanes, major hurricanes, category 4 to 5 hurricanes, and global percentage of hurricanes reaching category 4 to 5. So this has gotten lot of attention, that even though there is no increase in the total number of storms or cyclones, the number of storms reaching top categories 4 and 5 has increased, which is basically true here in terms of percentages. Again, looking at the different regions, if you look at the total number of hurricanes, there is a drop in the number. Major hurricanes, no real change, whereas if you look at category 4 and 5 hurricanes, there is a trend here, and again, it includes all these regions, as we already saw. Eastern North Pacific and North Atlantic here also are dominating. So obviously there are a lot of things to think about in terms of how the energy redistribution may be happening for short-lived storms lasting less than 2 days versus those lasting longer, and how warming and rapid intensification may be driving a higher percentage of storms reaching categories 4 and 5, right? So accumulated cyclone energy, a clear downward trend over this period of 1990 to 2021. So let's just keep our eyes on the global number. And rapid intensity event changes. So if you look at less than, so this is rapid weakening and rapid intensification. So you have no real trend in the, well, maybe there is a slight increase with a lot of scatter in the rapidly weakening storms, which is probably consistent with the shorter living storms. For example, here named storms lasting less than 2 days, less than or equal to 2 days have increased, whereas those lasting longer than 2 days have decreased. So there could be some consistency there, but you also have rapidly intensifying cyclones increasing in number, which is related to larger fraction of them reaching category 4 and 5. So you have to read in more detail if you want to follow this up. This is a debate that goes on, and this will hardly be the last word, I'm sure. So here, as in figure 2, but for accumulated cyclone energy, global rapid intensity change for 50 knot rapid intensification and minus 50 knot rapid weakening thresholds is what we saw here, and this one is as in figure 2 for damage in billions of dollars which have gone up, and almost all of it is coming from North Atlantic hurricanes because of the US, for example, occupying more and more of the high sea level storm surge inundation regions, rapidly intensifying hurricanes, and hurricanes moving slower and dumping more rain, and of course population increasing in the path of the hurricanes as well. As for the drivers, here are the trends in the shear. So increasing shear is a good indicator of a decrease in cyclone activities, but if you look at relative humidity also, there is a decrease, which is again going to add to the increased vertical shear in terms of reducing the number of named storms. Indian Ocean, not that significant, but the northern Indian Ocean, Western Arabian Sea have warmed presumably more rapidly in the summer months, but the cyclone season is in the pre-monsoon and post-monsoon. So one has to be careful about when the trend is looked at. So you can see that this region, which is warming rapidly, has higher relative humidity increasing trend. So this would be favorable for cyclogenesis. But if you look at potential intensity, the maximum wind speed you would get based on the SSTs, there are favorable conditions here in terms of the warming and the persistence of a cooler or less rapidly warming east versus the west is kind of maybe a player in the impact of cyclogenesis and potential intensity on western North Pacific and eastern North Pacific. But what is more telling is that if you look at sea surface temperatures which should favor cyclogenesis and potential intensity, is actually opposed by upper tropospheric temperature at 200 hectopascal, because warm upper level temperatures are basically going to make your Carnot cycle weaker or less efficient, because remember, the Carnot cycle of the cyclone is running from the warm sea surface temperature to the top of the atmosphere. If it's cold, then you have a more efficient cycle, but if the temperature difference is reduced, then you have basically you are opposing the potential intensity. So this is just looking at the El Nino index and arguing that the weakening trend, let's say, of the east-west gradient or the cooler eastern Pacific over the last few decades, over this period of 1990 to 2021, is consistent with decreasing cyclone activity in the western North Pacific, but increasing over here because La Nina brings more hurricanes, and the same for approximately the same for eastern North Pacific, even though they can be out of phase. Okay, so it's a very brief summary of a very nice paper. I wanted to include it here because this is a historical analysis which should give at least some guidance on what to look for as far as global warming response is considered in tropical cyclones, because it's possible that the story of more major category hurricanes could be true. And if the global warming response continues to be La Nina-like, then Western North Pacific could see decreases. But one has to be careful about storms lasting a shorter period, less than equal to 2 days, versus those that are lasting longer than 2 days, and so on. So at least realize that there are all kinds of ways in which this has to be looked at. So the story is still out, and Adam Sobel has another paper with Cape Vecchi and others arguing that basically it's been impossible to say what the cyclone response will be just in terms of frequencies to global warming. So we basically have no real evidence that the total number of cyclones will increase.